Okay, so if we have tubes that's closed at one end, so that we call that a closed tube. And if we look at figure 12.12a, we get an expression for fundamental frequency for a closed tube. So we know that the fundamental frequency is the speed of sound over 4 times the length of the tube. Now, this speed right here, this will change with temperature. So we have two different temperatures, so that's going to change our frequency. So if we want to take the um, so we know the fundamental frequency at 25 degrees Celsius. So so we know that the length is same for both of them, so our frequency will be proportional to our velocity. So let's take the ratio of frequencies at 25 and 31 and see if we can get the frequency at 31 degrees Celsius. So fundamental frequency at 31 degrees Celsius is something that we need to figure out. Frequency at 25 degrees Celsius is given, and then that's going to be our speed at excuse me 31 degrees Celsius over 4 times the length divided by speed at 25 degrees Celsius divided by 4 times the length. So we can get rid of these two guys. So we'll have velocity at 31 degrees Celsius over velocity at 25 degrees Celsius. And we can say from there is frequency at 31 degrees Celsius is frequency at 25 degrees Celsius times velocity at 31 degrees Celsius over velocity at 25 degrees Celsius. So we can, so our ultimate goal is to find the beat frequency. So since we know that the frequency will change, so our beat frequency will be the change between frequency at 31 degrees Celsius minus frequency at 25 degrees Celsius. So we have found out an expression for this. So if we put it there, we'll have frequency at 25 degrees Celsius, then our velocity at 31 over velocity at 25 Celsius minus frequency at 25 degrees Celsius. So if we take the frequency at 25 degrees Celsius out, we'll get this expression. And now, since we know all the numbers, we can easily put. Now, to get these two numbers, we can look at section 12.1 and we can find a relationship between our velocity at certain temperatures. So this is given as 331, which is the speed of sound at 0 degrees Celsius times 0.6 plus 0.6 times the temperature uh, meters per second. Now for 31, this is going to be 31. For 25, this is going to be 25. So we'll have 349 hertz. So that's the frequency at 25 degrees Celsius. Then we can write this expression, and that will give us 331 plus 0.6 times 31 divided by 331 plus 0.6 times 25 minus 1. And so the unit for this is going to be meters per second. Same here, and they will get rid of each other. So the final answer to that will be 3.63 hertz. So that's our beat frequency.